everyone, I'm Comic Christina and welcome to our last lesson of Abracadabra paper puzzles. So from your Abracadabra kit, you're going to need your paper puzzles bag, and then from home, you're going to need either a pen or a marker, a pair of scissors, a ruler, or in my case, some measuring tape, some Scotch tape, and any hardcover book. I'm going to be using my Wizard of Oz copy today. So go ahead and get all your materials collected and then we can get started. All right, now we're going to do our really awesome Mobius band activity. So from your bag, you're going to need your piece of colored construction paper. From home, you're going to need either a pen or a marker, a pair of scissors, a ruler or some measuring tape, and some Scotch tape. So the first thing we're going to do is we're going to cut our colored paper into two strips that are 2 inches by 11 inches. So your construction paper should be 12 inches long. So we're just going to cut 1 inch off of the edge here. So I'm just going to use my tape to do that. So I'm just going to put this down. I'm going to see where the 11 is, and I'm just going to kind of mark it so that I can cut off that strip. And then actually while I'm here, I'm going to go ahead and measure out my 2-inch wide strips. So on this side, we want 2 inches and 2 inches. So I'm just going to start here at the corner, and I'm just going to mark my 2 inches. It doesn't have to be super exact. You just want it to be kind of close. And I'll show you what mine looks like so you can make sure yours is similar in size. So I cut off my little 1 inch at the end, and then now I'm going to cut my 2-inch strips. Okay, so your strip should look about like this. So about that wide and that long. Okay, so we're going to start with one of these strips, and we're going to make something called a Mobius band. So go ahead and take a piece of tape. I got the best results using quite a bit of tape because we're going to be doing some cutting. We want to make sure it sticks together. So I'm going to go ahead and make myself a tape donut that's about as wide as my strip of paper. We don't want it too skinny. We want it pretty wide. I'm going to put that over there. And we're going to take our strip of paper, and you're going to make a ring like this, but don't tape anything yet because now we're going to take one side of the paper and just do a little half twist like that. So just take the paper and do a little half twist. And then now we're going to tape it together. We're going to tape it 2 different ways. First, I'm going to put my tape donut there and put that right down on it just like that. You don't want to put the pieces of paper too far overlapping because we do want to keep some length. And then once that paper tape donut is there and they're attached, I'm going to take a pretty long strip of tape and I'm going to tape all the way around that piece of paper. Here, I'll show you when I'm done. So just like that, taped all the way around so it's completely covered by the tape on both sides. So it's taped nice and well. Okay, once you're finished doing that, let me ask you a question. In this shape, is there one side to the piece of paper or 2 sides? What do you think? We can actually test this out by taking either our pen or a marker, and I want you to draw a line right down the middle of the piece of paper until your line meets the other line. So let's see what happens. I'm going to start where my tape is. And I'm just going to start drawing a straight line. You might have to pause sometimes to like kind of unroll your paper so you can draw on it. It doesn't have to be a perfectly straight line, just do the best you can. Okay, so I've gotten to where the tape is, but my line is on the other side of paper. So I'm going to keep going. Draw through that tape there. Keep drawing. Okay, so my lines did eventually meet together. So what that means is that this piece of paper has one side. Because it does eventually meet together. If it was two sides, our lines never would have met. We would have ended up drawing one line, it would have met, and the other side of paper would not have been drawn on. But because it went all the way around the piece of paper, that means that this is somehow now one-sided. So this is called a Mobius band, and it's named after a mathematician named August Ferdinand Mobius. And he studied topography, which is the study of different shapes and kind of manipulating them into different forms and shapes. So that's what topography is called. So we're going to do some experiments with topography using our Mobius band. So the first thing we're going to do is you're going to take your pair of scissors and we're going to make a cut all the way around our piece of paper, right where we just drew that line right in the middle. So the easiest way to do this is find a section away from your tape and just kind of bend it a little bit like this. And then you can start that cut right there in the middle, just like that. And then now we're going to open that up because now there's room for our scissors. And we're going to make that cut. So while I'm cutting, what do you think is going to happen when we cut this piece of paper all the way down the middle? Normally, if we did that to two pieces of paper or a one-sided piece of paper, it would just make two rings, right? Two rings of paper, because we cut it in half, we made two equal size rings. Okay, let's see if that's what happens here. Okay, it made one ring, one big ring. It's got some curves in it, but it made one big ring. So now, let's do that again. Let's take our piece of paper, fold it in half, just like this, and we're going to cut again right down the middle. Try to keep your lines down the middle because we don't want any of the pieces to be too thin, because we're going to be doing quite a bit of cutting here, so we want to make sure we're leaving ourselves enough paper to get all of our cuts in. So we're going to cut it down the middle again. So the first time it made one really big loop. So what do you think is going to happen this time? Are we going to make another really big loop of paper? Are we going to make two separate loops of paper this time? Let's see. Try to keep your cut as close to the center as possible, because we're still going to be making another cut after this to our paper. Okay, there we go. This is why it's important that things are taped well, because we keep cutting through the tape. I want to make sure things stick together like they're supposed to. All right, so now we have two interlocking loops of paper. All right, so we're going to do this one more time. We're going to cut down the middle of each of our loops of paper and see what happens. Do you think maybe it'll open up this time and we'll get this really big long loop? Do you think they'll finally separate? Do you think it'll make a different shape? Let's see. So we're going to do the same thing again. I'm going to bend it to start my cut. This one's going to take a little bit longer because now I've got two loops to cut through. And this is why we wanted to make sure we left enough paper, because if we were not cutting down the middle, one of our sides of paper would have ended up being really thin, and it would have been very hard to get another cut down the middle. So this is a little bit tricky because you gotta kind of like move things out of the way, kind of follow the loop. Now there's another piece of paper in the way. So just take your time and cut down the middle as best you can, being careful not to cut through any of the loops. You want to stay in the middle of that paper. So just be patient and take your time cutting through there. Just one little bit at a time. Okay, one loop's done, but I'm not going to open that until I finish my other loop, because I want to see the finished result. So now I'm going to go on the other side. I'm going to make my cut and my fold, just like last time. And now I'm going to start cutting down the middle. Move some stuff out of the way. Here we go. now for the reveal. Let's see what happened. I'm gonna open up each of my bands. Okay, a little bit tangled, but if you look at this, now we have 4 intersecting loops. So we went from 1 big loop to 2 intersecting loops to now 4 intersecting loops. So this is an example of topography. We're using the manipulation of shapes and kind of using the Mobius band, so a continuous surface. That's why we got different results than if we had just cut a ring in the piece of paper and then cut it in half. We would have ended up with 2 separate loops rather than the 1 long one. And it never would have done this kind of origami manipulation of shapes kind of thing. All right, so we have another strip of paper. So we're going to do this activity again, but we're going to cut the paper in a little bit different way this time to see if we get different results. So now, take the paper like this. Actually first, let me get my tape donut together because that's important. We're gonna tape it the same way as last time. We're gonna use a tape donut. You want it to be about as wide as the piece of paper. So I'm gonna put that there to get it ready. And then we're gonna tape around again. So it's the same thing. You're gonna put it like this, like a ring, and then you're gonna do a little half twist. Okay, and then we're gonna put our donut here. So take the paper, half twist, and then tape it together. And then again, I'm gonna get a long strip of tape because I want it to cover where these 2 pieces of paper comes together all the way around to make sure it's nice and taped so everything stays together while we're making our cuts. There we go. Okay. So this time, instead of making a cut in the middle, we want to make a cut about 1/3 of the way from the side. So you can measure if you want to see what 1/3 would be. If it's 2 inches, it'd be about 3/4 of an inch. So we're going to do the same thing. I'm going to get away from the tape. I'm going to bend it. And I'm going to cut about 1/3 up from the bottom. So rather than in the middle, you can see here, my cut's kind of like here. So it's less than half. Okay, and now we're going to cut all the way around, staying about 1/3 from the edge. And what do you think is going to happen this time? Last time we got a big loop, right? Just cutting down the middle. Okay, as you can see, when I've gotten to this point, here's my first cut up here at the top. Here's my bottom cut. We're going to keep going. We're going to keep going and see what happens. And eventually, almost like kind of magic, you do end up coming around to the beginning of your first cut. All right, now we're going to see what happens. Okay, so this time I actually ended up with 2 separate pieces of paper, 2 separate rings that are interlocking each other. So that is pretty neat. So you can experiment a little bit. You have more construction paper. If you want to try to just make a regular loop and see what the difference is when you cut it in those ways from what we just did. And actually you can even look up, there's a lot of really cool YouTube videos with lots of different Mobius band tricks that you can do using construction paper, tape, and some scissors. So that was pretty neat. Not at all the results that I was expecting. So topography, not usually a fan of math, but I think topography might be one that I can get behind because that was pretty fun. All right, now we're going to do another example using topography and do our paper door puzzle. So you're going to need your paper door puzzle from your kit. So you should have 3 copies of this in your kit and just a pair of scissors. So looking at this piece of paper, it's a normal size piece of paper. Do you think there's any way that we could get this piece of paper big enough without changing its dimensions to be able to walk through it just like a door? So make it that big. I don't know, kind of hard to believe. So we're going to use topography and we're going to use the outline on this paper to change the shape of it, but not the dimensions, and see if we can make it bigger. So the first thing you want to do is you want to fold it across this center line like this. gonna cut along all of the lines. First, you wanna start with these lines here on the side. So just pick one side of the paper so you see on this side how all the lines go up, but not all the way to the top. We're going to cut all of these first. So you'll be cutting it on both sides, so keep your paper bent and just make a lot of straight lines. So I am having a hard time understanding how cutting just straight lines, we could change this piece of paper to be big enough to walk through. I would think we'd be cutting something like circles or squares or something to kind of open it up, but no, just straight lines. Okay, now we want to go to the other side and see where it meets the end of the paper here and kind of goes up but not all the way. We want to cut from the bottom to the top here. Not all the way through, just to the top of the line. So we're going to now come from the other side and cut these lines. So it's important not to cut outside of the lines because we don't want to ever cut through the piece of paper. So staying on the lines is very important to creating our shape. Okay, now, even though we folded along this middle line here, it's still a line. So we want to cut through that. We want to cut through this middle line where we folded, but you do not want to cut through these end pieces because there was no line there. You want to keep those intact. So I'm just going to take my pieces that I folded like this, and I'm just going to cut across the top. I'm just going to stick my scissors in between my two pieces and cut along there. I'm going to do that to all of my little folds here at the top of the paper. Okay, so I am definitely curious because to fit through a door, need an adult-sized door. I can't just use a kid-sized door. So I'm not sure how this little piece of paper is going to end up being big enough just because we made a bunch of straight lines. But I have cut through all my lines now, so I'm ready to open this up and see what it looks like. Okay, so that is one big circle. That's pretty big. So we didn't change the dimensions of the paper. We didn't. We just manipulated the way that it was cut. And let's see if this is big enough to go across my body. Oh, definitely. If I put this on the floor, I could easily pull this up over my body. Is yours this big too? So this is why we didn't want to cut through any of the lines because we need them to stay connected. But we did definitely change the shape without changing the dimensions. So we really expanded our piece of paper to make our paper door. So you have a couple more of these. I mean, we went from this size to this size, so that's a big difference. So you can try this a few times and see if you can make quite a few paper door puzzles using topography. Okay, now we're going to do our paper butterfly surprise. So I'm really excited about this because I love butterflies. They're one of my all-time favorite things, and I love science, so we're combining two of the things that I really love together. Okay, so we're going to open our flying butterfly. And then you also need your hardback book for this one too. Okay, so mine's kind of taped down, so I'm just going to pull that off. Perfect. Here we go. All right, so we are going to be using our paper butterfly and demonstrating different kinds of energy. We're going to talk about potential and kinetic energy. So potential energy is stored energy. It's energy that's not in motion yet, but the energy is stored and ready to go. Kinetic energy is energy in motion. So an example of this is, have you ever ridden a roller coaster? So when you get to the top of that hill, you have built up your potential energy and you're just sitting at the top, and there's just this moment where you're sitting still before you go down. When you're going down, that's kinetic energy. It's the same thing as like bouncing a basketball. When you bounce a basketball or dribble it, when you hit it against the ground, there's this moment where the ball is at rest, but it has hit the other surface and it's building up this potential energy to bounce back up. So the harder we bounce that ball, the further up it goes, because that's more stored energy that we gave it. And then the kinetic energy is the energy that's taking all that energy we gave it and putting it in motion. So kind of like for every reaction, there's an equal and opposite reaction, that kind of thing. So two concepts of science. All right, so I'm gonna open my book. There we go. And now I'm going to twist up my butterfly. And you're gonna do that by just twisting the top wings. So just twist, twist, twist. And then what we're actually doing right now is we are creating this stored energy in our rubber band in the center. So when we're finished turning it, we're gonna hold it in place. Is our butterfly in motion right now? No. But did we actually put some energy into our butterfly? We did. We put energy into the rubber band. So right now it's stored or potential energy. So you're gonna set your butterfly down, being sure not to let go of those top wings, hold it in place, and then close your book. We're gonna leave it there for a second because we're gonna talk about what do you think is gonna happen. Right now our butterfly has all this stored potential energy and the book is holding it closed, just like our fingers were. So we're gonna open the book and see what happens to our potential energy that we stored up. All right, let's do that again because I thought that was really cool. So I'm gonna turn it. You don't wanna overturn it because we don't wanna break our rubber band, but we can put quite a bit in there. All right, so I'm gonna put it in my book again, close it, and then let's see what happens. Oh, that one was not as good. It did not fly up. But you can kind of do this to trick people. There are actually like envelopes that people put these in and the butterflies like this pop out to kind of scare people. But as long as it's held in place and twisted up, that potential energy will stay stored until the butterfly can freely move. And then that potential energy is going to get released into this kinetic energy. And because of the shape of the butterfly, it actually causes it to fly. So that's a really cool, awesome example of potential and kinetic energy. All right, now we're going to use topography again to make an impossible paper puzzle. So you're going to need just one of your plain sheets of printer paper from your bag, and then you're going to need a pair of scissors. So the first thing we're going to do is we're going to fold our piece of paper long ways like this in half. So just like this, and then we're going to open it up. Okay? So on one side of our fold, we're going to cut our paper into 2/3 shapes. So you're going to put one square about 1/3 and the other square should be about 1/3. So you should end up with 3 somewhat equal squares. It doesn't have to be perfect. I'll show you what it looks like when I'm done. And just cut up to the fold. You don't want to go any further than the fold. So just like this. So 3 somewhat equal squares. And we stopped at the fold line. Now on the other side, we're going to cut this piece of paper in half. On the same side, up to the fold. So it should be about middle way through that middle box on the other side. So kind of like this. Okay? So 3 boxes on this side, 2 rectangles really on this side. Okay, so now you're going to set the piece of paper down. All right, and I'm going to set it down so that my 3 boxes are on my left-hand side and my 2 boxes are on my right-hand side. And then we're just going to take one of the top folds of the side with the 2 boxes like this, and we're going to fold it under and then open up our piece of paper. So it should look like this now. Okay, so again, you're going to take the side that has the 2 boxes and just flip it under like that. So just twist it and then put your piece of paper down. So now, even though we haven't changed the dimensions of our paper, now we're kind of left with this impossible puzzle. If you look at it, no matter how I turn this, it does not fit into a normal piece of paper anymore. So even though we only made 3 cuts and we just twisted it one way, now this flap, no matter which way I put it, it can't, like if I put it this way, it overlaps on this side. If I put it on this way, it overlaps on this side. So we now have what looks to be the same amount of paper as we started with, but we can't make just a perfect sheet of paper anymore. So we've manipulated the shapes a little bit. It's kind of created this optical illusion using topography. All right, guys, so that's the end of our paper puzzles lesson. I hope you learned some really cool things about new stuff with topography and Mobius bands and potential and kinetic energy, and now you should know all kinds of really cool science tricks and experiments to share with your friends and family. I hope you had fun, and I hope that I'll see you at our next topic. It's called Is There a Doctor in the House?, where we're going to be learning all about different things with the human body and different things about being a doctor and maybe what that looks like. So if you have an interest in biology, science, or maybe even becoming a doctor one day, this should be a really fun topic for you. All right, guys, see you next time.